The method I went about solving this hurricane problem was by using the kinetic energy of the wind force that the hurricane would generate. First, to get the dimensions of the hurricane, I googled eye wall thickness to be about 20 to 40 miles wide, so I estimated it to be 30 miles, which is corresponding to 48 kilometers. I then found that the hurricane force winds can be anywhere from 25 to 150 miles out, so I estimated it to be 80 miles or 129 kilometers, and then found that the average hurricane total width is going to be somewhere around 300 miles or about 482 kilometers. And for this remaining section, we're going to be estimating that they're going to be gale force winds, which is about 33 to 40 knots. So the gale force winds are going to be about 68 kilometers an hour, and we're going to assume this is a Category 3 hurricane. So the hurricane force winds are going to be about at 195 kilometers per hour. The height is going to be about 10 kilometers, and the sea level density is going to be 23.77 10 to the negative 4 slugs per cubic foot, and at the top about 7.38. I then converted that to kilograms per kilometer cubed and took the average of the two to figure out the uniform air density that I'd be using for the entire volume of the hurricane. So to figure the volumes out, I broke it into two sections. So for the hurricane force wind, we took the radius and subtracted the volume of the eye to get 166,000 kilometers cubed for just this hurricane force wind section. And then did the similar approach for the gale force wind by taking half the distance to get the radius all the way out, and then subtracting from this distance just to get this volume right here for the gale force winds. And that's going to be about 1.6 million kilometers cubed. And then use the kinetic energy formula to find the energy for each section, where you plug the numbers in here for the mass of the air and then the hurricane force wind velocity, and same thing for the gale force, except using the different volume in 68 kilometers per hour. These units are in kilometers squared over hours squared though, so I had to convert it to meters squared over kilograms meters squared over seconds squared using this conversion factor for joules. And then adding the two together, if you round up, it's going to be about a magnitude of 18, 10 to the 18 joules. But it can be anywhere from 10 to the 17 to 10 to the 18. But this is just an estimate, so it's going to vary greatly. But this is what I got.